Good morning, one and all. This is Dr. P SREENIVASULU, presently working as associate professor in Alsankara College of Engineering and Technology. Today, we are going to discuss about operational amplifier. Operational amplifier is a multi-stage, high-gain, direct coupled amplifier. Operational amplifier is a multi-stage, high-gain, direct coupled amplifier. So you see the basic information about op-amp. You see the circuit op-amp symbol, the device symbol. It is like a triangular shape. There is a inverting terminal. There is two input terminals, one output terminal. One is an inverting input terminal. Another one is non-inverting input terminal and output terminal. So why it is a inverting, why it is a non-inverting? So if you apply input to the inverting mode, and if you connect this non-inverting input terminal to ground, so the output if you see, it is called inverting input. If you apply input for non-inverting input and inverting terminal is connected to ground, it is operated in non-inverting mode. If you apply inputs for both, it is called in differential mode. So these are the three modes in operational amplifier. Now, this operational amplifier is available in IC form. So different manufacturers, they have developed the different formats of ICs. Now, commonly used IC, that is, these are the different formats of ICs developed by different manufacturers. Now, in the laboratory, we are going to see the IC format is like this. It is a mini dip IC. You see a 8-pin mini dip. Now it is a 8-pin IC. The pin diagram of op-amp is very important. Now there is a two offset nulls, 1 and 5 are offset nulls. 2 is a inverting input, 3 is a non-inverting input, and this op-amp requires two power supplies. One is a negative power supply, another one is positive power supply, because internally there is a emitter coupled differential amplifier. So collector requires positive supply, emitter requires negative supply. So minus VEE plus VCC. This VEE is connected to 4th terminal. This VCC is connected to 7th terminal, and output is a 6th terminal. So one input 8 is there is no connection for this. It is the pin diagram of 741 IC. If you want to connect any circuit, if you want to design any circuit, it is easily connect by using 741 IC. It is a brief idea of 741 IC. Now, the way of connecting power supplies, it is also important. So for whatever we have seen the circuits, whether it is amplifiers or it is biasing concepts in electronics, only most of the time we are using only single supply. Now here if we observe, one supply is a plus VCC, another supply is a minus VEE. This positive terminal of the battery is connected to plus VCC, and coming for minus VEE, the negative terminal of the battery is connected to negative supply, minus VCC, minus VEE, and whatever the remaining in the positive battery negative, in the negative battery positive, it is going to be connected one reference point, that is we are going to be called ground potential. It is the way of connection of supply to the op-amp. It is also keep in mind. So you see here different ICs, different manufacturers, they have developed the IC. So there is a Fairchild, National Semiconductor, Motorola, RCA, Texas Instruments, and Cytex, Barry Brown. These are all manufacturer of this op amp. Now, whatever we are using, IC741, it is developed by this National Semiconductor. It is a LM741, MC1741, CA3741. These are all different ICs are available. Now, we are using generally this 741 IC. So, this 741 IC, if you see this op amp, any designer, whenever we are designing a circuit diagram, whether it is an amplifier or attenuator or it is a filter or any system, or it is a diode or BJT or FET or amplifier, we must have some goals. We must have some goals. So like that, while we are designing an operational amplifier, we need to have some goals. That goals are called here ideal operational amplifier or ideal characteristics. In the ideal characteristics, we are going to see 6 or 7 parameters. These are very important. You see, first one, open loop voltage gain. It is generally for any amplifier. While we are designing any amplifier, the gain, voltage gain, means output voltage by input voltage, is always high. We want always, because we are designing an amplifier. The motto of amplifier, we need to extract more gain from any device. So that's why it is a open loop voltage gain. So ideally, we are expecting infinity. But practically, we are not going to achieve that value. But we must have some goals. Next, always while we are designing an amplifier, input impedance is very high, we require. So input impedance is high, then only it is going to be avoid the loading effect on signals. Whenever we are applying a signal, suppose the impedance is low, it draws more current from the signal source. So that is going to become for a more load on the signal source. So within a very short span of time, that the signal source is going to be damaged. That's why always while we are designing an amplifier, but try to choose that input impedance is very high. So that's why here the goal is input impedance of operational amplifier is infinity. Next, always amplifier output impedance is low, because we need to draw more current from the output. It can drive for remaining circuits. It is a source for remaining all circuits. So as well as try to get more current. So if you want more current, impedance must be low. So that's why the output impedance is 0. Next, bandwidth. If you design any system, any amplifier, whatever the system, bandwidth means the range of frequencies we are going to be operate that particular device. So what is our aim generally? That device must be operated for all frequencies. Then only it is a good device. But coming for electronics, because all are semiconductors, so these are all depends upon temperature. So that is not at all possible to get the whatever the designed amplifier or designed circuit. This performance is not same for all frequencies. So our idea is the bandwidth must be infinity. But while coming for practicality, there must be some depends upon the system. Now here our goal is the bandwidth of the op amp is must be infinity. So but practically it is in the order of megahertz. It is somewhat better compared with your existence of BJT. Next, there is another word, zero offset. So zero offset means in the amplifier there is a problem because there is a two input terminals. Generally, for any system, any amplifier, whenever if we connect input is zero, usually we are expected the output must be zero. But here, whenever if we connect V1 is equal to V2 is equal to 0, means that input terminals are connected to ground potential, but the output may get some less voltage. It is because it is a directly coupled amplifier. Operational amplifier is a directly coupled amplifier. So whenever there is some noise is generated, that noise gets amplified. So noise in the order of microamperes, microvolts or millivolts. We don't know exactly how much voltage, how much noise voltage is generated in between the terminals. So it is very less. But even this less noise voltage also it can be amplified. So that is the problem in operational amplifier. So we need to check whenever V1 and V2 are connected to ground, whether the output is going to be get zero or not. Suppose it is not getting zero, it is in the order of some millivolts. So that is going to be minimized by external circuit. That is called here zero offset. Another thing we need to remember here, whenever this is either of the input terminals, there is a two input terminals here. The either of the input terminals draws no current. That is our idea of ideal op amp, because the input impedance of the op amp is infinity. So whenever the input impedance of op amp is infinity, it draws no current. So whenever it draws no current, there is a two terminals in the input. I1 is equal to I2 is equal to 0. So it is also one more important uh, characteristics. Like a characteristic, you need to remember. Along with these characteristics, we need to remember the extra three parameters. And one more thing, the voltage difference between non-inverting terminal and inverting terminal must be 0. The voltage difference between non-inverting terminal and inverting terminal must be 0. Vd is equal to 0. It is because the open loop voltage gain is infinity. So what is the open loop voltage gain? V0 divided by the difference between the two terminals Vd. So when it is going to be at infinity, definitely Vd is equal to 0. So that's why the difference between, always we need to assume in ideal case, the difference between the two terminals must be 0. And there is one more parameter, slew rate. Slew rate is usually while we are designing the circuit diagram, previously I have said for bandwidth also, it must be operated for same for all frequencies. We are coming for this slew rate concept, whenever if we take a simple circuit voltage follower. So the purpose of voltage follower is whatever the input voltage we are giving, we are going to expect output is also same. But if it is a sinusoidal signal, there is no any problem. It can respond for all the frequencies and we will get the input and output are same. But we are coming for a square wave. Square means there is a sudden change, there is an abrupt change from high to low, low to high. When this case, There is an internal capacity because the op amp is a entirely it is depends upon by using whether it is BJTs or it is FET. So internally, there at high frequencies, we need to consider the junction capacitance because it is going to be operated at the op amp is at low frequency. There is no problem with slew rate. Whenever it is at high frequency means the time is in terms of microseconds. It is in microseconds means very fastly it can be changed. But whenever there is a junction capacitance, if we consider, these are not going to be respond very fastly. It takes some time. So that's why whenever there is at high frequency, if you want to apply a square wave for a op amp, there is a problem. The entire shape is going to be changed. So that is called slew rate, the maximum rate of change of output voltage. So that's why we are expecting slew rate is also infinite. Means, what does it mean infinity means? Whenever time changes, simultaneously the output is also need to be changed. That is we are expecting. But it is not done in op amp. That is one more important characteristic you need to write here. The one more thing is a common mode rejection ratio. It is also important. The common mode rejection ratio, CMRR, it is the ratio of common mode gain to difference mode gain to common mode. Previously, I said just before, we want only it is operated in difference mode. Different amplifier is designed for different operational amplifier is designed for differential mode. Even though whenever if it is connected to ground, there may be some noise is present. That is an unwanted thing. So it is called a common mode. So we want to reject this common mode gain. So that's why always you need to calculate the ratio of difference mode gain to common mode gain. So this difference mode gain to common mode gain, always it is a infinity because our aim is common mode gain is going to be make 0. Whenever it is 0, then CMRR is going to be get infinity. But practically it is going to be get high value because the common mode gain is less. So it is also another important characteristics of ideal op amp. So today I am going to stop. Tomorrow we will see the concept of operational amplifier, how we are going to be used it.